Whether it's a lineman stuffing a running back or a safety colliding with the wide receiver, all NFL defenders have a single-minded goal: to stop the ball carrier. The object of making a tackle is so you want to get the guy down and limit the amount of yards he's able to gain, especially after contact. Overall, in this project, my essential question is, what is the best way to get the most force and momentum out of a tackle to knock down the offensive ball carrier? When a tackle is performed correctly, it's a depiction of Newton's third law of motion, sometimes called the action-reaction law. Newton's third law says that each action or force has an equal and opposite reaction. So if I were to push against a body, that body is going to push back against me with an equal and opposite force. An important part of Newton's third law is the concept of momentum, which in football is the mass of a player multiplied his velocity, represented by the formula P equals mv. It's very important to have some speed and momentum as you're going in to make the tackle. The better you're able to use that to your advantage, the better you're able to make contact and get a guy down right away. In every collision on the football field, Newton's third law dictates that the total momentum between players must be the same before the collision as it is after the collision. This relationship is referred to as conservation of momentum. The law of conservation of momentum says that the P, the momentum before the collision, is equal to P, the momentum after the collision. This law, represented by the formula P before equals P after, can be illustrated with a simple toy called a Newton's Cradle. In this case, we have displaced an initial sphere, and when we let it go, it has some momentum, its mass times velocity. When it impacts the next sphere, that momentum is transferred through the middle three spheres and then passed on to the final sphere, and so because it has the same mass, it will move away with the same velocity that the first sphere impacted the middle spheres with. The interaction of balls on a Newton's cradle can help illustrate what's known as an elastic collision. On the football field, collisions are typically inelastic collisions, because kinetic energy is released mostly in the form of compression between the players' bodies and sound waves. Newton's second law can also be applied to the physics of tackling, as the second law states that the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force. The second law is expressed in the equation force equals mass times acceleration. The second law can be applied as when a defender has a lot of acceleration, no acceleration, or anywhere in between. An example of a defender with no acceleration is shown here as the defender is hit by another accelerating object and is violently hit towards the ground. Therefore, we can say the defender had no acceleration, giving him no force either, to counteract the offensive player's momentum. On the other hand, here's an example of a defender with a large amount of acceleration and therefore tackling the offensive player, and as the defensive player does this, he is therefore transferring his momentum and force into the offensive player. So in the end, whether a tackle is successful or not, we can be certain that the same force is exerted on both players and the total momentum before and after the collision is the same. Plus, without acceleration, we have found out that there is no force and therefore no tackle. So for both these reasons, we have Newton's third and second law to thank. Also, a huge thank you to Sports Science Lab for providing me with crucial data I used to create this project. Thank you.